All right, hello everyone. We are continuing right along now onto the second part of the video for section 1.2, doing some more of a domain and range of functions. And now we're going to look at, we looked already with an example of finding the domain and range of a function. So I'm going to look at now finding the domain and range of a function from a graph. Now, just to remind ourselves, recall the domain of a function, that's the set of all inputs in the function, right? And on a graph, the inputs are the things that appear along the horizontal axis. So I'll label that here. This will say inputs. And then the range is the set of all possible outputs. So those are the things along the vertical axis then. Okay, so to find a domain and range here, we need to look at the values along the horizontal axis and the vertical axis that are covered by this graph. So notice, in this particular picture, if we're looking for the domain, so we're looking left to right at the values that are covered, and it looks like it goes from this point here to this point here, right? And so that first number looks like it is -5, and we're going to write these in interval notation, up to the other number there on the right, 2, 4, 6 is 8. So our interval notation for the domain here looks like -5, comma 8. And then we have to think about, are there parentheses or brackets on these? It looks like, first of all, at both points we have closed dots, so it would be parentheses, meaning they're both included. Okay, so that's for the domain. Again, looking at the inputs, the things along the horizontal axis that are covered by this graph. Next, then, we need to look at the range, which will be the values up and down on the vertical axis that are covered. Looks like the lowest one is here. And then be careful, the highest one is not here. Folks will often think that it's that because that corresponds with the dot over there on the right, but that is not true. It actually goes higher than that. So go up to this point here would be the highest. Okay, so that lowest point there then looks like it'd be -2, -4, -6, -8, -9, comma, the highest one there looks like it gets up to -2. And the -9, we see there's a closed dot, so that's definitely included. The -2, it's kind of hard to tell, although it looks like it goes straight through that point there that I just tried to circle with the green, so I think we would say that that's included as well, so that will also be a bracket. So our domain here is -5, comma 8, both with brackets, and then our range is bracket -9, comma -2 bracket. Okay. All right, let's look at another example of finding domain and range from a graph. And this time we're going to use one of our toolkit functions. So recall your toolkit functions are a set of functions that we should be memorizing and knowing things about because they're going to come up many times throughout the quarter. So this one, assuming you've been studying them, this is what is called the reciprocal squared toolkit, and its equation is f of x equals 1 over x squared. And I want to write the domain and range of this function. -infinity. We also see that it goes off to the right forever, so it looks like the highest value would be +infinity. So this should be an example where we have all real numbers, right? No, because notice what happens in the middle here. And I'm looking right along here. Notice that coming from each side, right, the graph is getting closer and closer to some input value, some value horizontal axis there, but never actually approaching it. And that's what we see with these arrows up here, is they're getting closer and closer to some value, but never actually touching them. And what value does that appear to be? Well, it's the one right there in the center, which is 0, right? So 0 is not actually included in the domain of the reciprocal squared function. Okay, so just kind of like we saw in one of our examples before, then to write the domain here, we'll have negative infinity up to 0, because again, looking at the horizontal axis, you can cover all values of negative infinity up to, but it stops here at 0. Similarly, on the positive side, we start at 0, not including it, right? And then we can go up as high as we want to positive infinity. So we'd start like right here and then go up this way forever, but we can't actually hit 0. So our domain looks like negative infinity, 0, union, should be there in the middle. Sorry, I meant to write that in a different way. There we go. And then 0, comma infinity. And again, that's because the 0 is not included in the domain. All right, for the range then, again, now we're looking at values, the output values, so values along the vertical axis. And notice we see, again, those arrows going up and up and up, which looks like then our largest possible value for the range would be positive infinity. What's the lowest value going to be as we go down? Well, notice as we're going along here, we're getting covered, but then we kind of seem to stop right around here, right? Because notice down below that axis, there are no values. The graph is not covering anything on either side of here. So it's going to be no output values there. And then as it comes down, right, from below or from above, it's getting closer and closer to some value here. We see the kind of lines going along right here. What would be that value it's getting closer and closer to? Yes, that would be 0 again. So not included. We get closer and closer to it. So our range here would be parentheses 0, comma, infinity. All right. And there's our domain and range. Great. All right, let's look now at finding domain using formulas. And I'll tell you right now, it's really difficult to find ranges of functions using their formulas. So we're not going to go over that, but finding domains we can. And in fact, we've sort of already done this, right? So here we're trying to find the domain of each of these functions. You know, the domain is a set of all possible inputs, so things that can be put into the function. And notice here on this first one, we have 4 times the square root of 4 minus x. So we see a root here, which if you recall from our prereq material, when we see that, we want to focus underneath the root. So this 4 minus x. And what do we remember about that? Right, it cannot be less than 0. It can be 0 or it can be anything bigger, just cannot be 0. So how do we deal with that? Well, we set up an inequality. So we'll do 4 minus x greater than or equal to 0. Go ahead and solve that by subtracting 4 from both sides. Do that. 4's can't negative, or the 4 and negative 4 cancel. We'll have negative x greater than or equal to negative 4. Can divide by negative 1 on both sides. So we end up with x, and because we divided by a negative, it flips our inequality. So we'll have x is less than or equal to positive 4 as our domain for this function. And because we've been doing with all the rest of them, let's write this in interval notation. So the domain here, being that x is less than or equal to 4, means it's 4 everything below. So we actually would have in this negative infinity comma 4, because it's 4 and everything below that, right? The negative infinity, put a parenthesis, because we always use that with infinities, because it's not actually a value we can reach. We went to 4 because it's less than or equal to, and that means the 4 is included, so we'll put a bracket here. All right, so we have negative infinity, comma, 4, bracket, parenthesis on the negative infinity. That's the domain of that first function. All right. What about the second one then? We have h of x equals 2 over 3x minus 1. Well, to find the domain here, think about what can be put into the function. In this case, what we have to be careful of is in the denominator, we cannot have 0, right? So 3x minus 1 here cannot be equal to 0. So in order to help us find our domain, we should figure out what does make that equal to 0. So we'll set up an equation. 3x minus 1 equals 0. Go ahead and add 1 to both sides. So if 3x equals 1, and then divide by 3 on both sides. When we do that, we end up with x equals 1/3. Okay, so that cannot be in our domain because we make the denominator here equal to 0. If we think about it, there's no other restrictions on what x can be, right? It can be anything below 1/3, it could be 0, it could be negative numbers, it could be anything above 1/3, 1, 2, a billion, 500 over 3, any of those sorts of things, right? So based on that, our domain then can have anything except for 1/3. So that means we can have everything down to negative infinity, all the way up to, again, 1/3, but not including 1/3. So put in a parenthesis there. And then a union, and again, we start at 1/3 because we can't have it, all the way up to positive infinity. Okay, so our domain is negative infinity, 1/3, union, 1/3 to infinity, parentheses on everything. Okay. All right, that's all for now. Thank you for watching.